1. Welcome back. Here we are in section 4.4. I'm going to start working through the homework. Specific homework questions are posted on the blog for the questions you need to complete. Here I'm going to be going through question 1 and I'll be doing D as an example. So let's go take a look at the book. Question 1. So without solving, determine the number of solutions for each trigonometric equation in the specified domain and explain your reasoning. So D is asking us to do secant theta, where it's equal to 2 over root 3 over 3 in the domain of negative 180 degrees up through to 180 degrees. So let's go take a look at what all that means. All right, so they want us to do minus 180 degrees less than theta, and then up to 180 degrees greater than theta. Now when we're doing the question, this here means theta is greater than or equal to 180. So if minus 180 is a valid response, you can leave that in. But over here, theta is less than 180 degrees. So if positive 180 degrees is a response, it's telling us not to include that in the answer. So now when you're working through these types of questions, you want to try and remember what are the trigonometric equations that are involved, and if you need to refer to what any of those are, go back to page 192 for a reference, and it'll tell you, cos is equal to x and sine is equal to y and all those. So when you're working on that, make sure to refer back to the page. So if I'm dealing with secant, keep in mind that secant is equal to 1 over cos theta. I always seem to forget the theta there. So secant theta is equal to 1 over cos theta. And remember that cos theta is x. So what they're saying here is that secant theta is equal to 1 over x. Okay? So that's the important part to think about when we're dealing with that. So here, if we're talking about secant theta where it's equal to 2 root 3 over 3, what they've done, they've rationalized this answer. Because remember, we don't have any 2 root 3s over 3s as answers. So this would actually be 2 over root 3, and the way they did that is they multiplied it by root 3 over root 3. So 2 times root 3 gives us 2 root 3 over, and root 3 times root 3 is simply 3. So just keep in mind this is a different way to express 2 over root 3. So now if we're talking about 2 root 3 over 3, or better yet, let's think about this in terms of 2 over root 3, because that'll help with the triangles to figure out where it would be. The important part to remember is this is positive. So we'll identify that as positive. So when we go up to look at this, we need to think about where is x positive. So x is positive here, which means that in quadrant 1 or in quadrant 4, we can have valid responses. So if we're thinking about the domain for minus 180 degrees, we're talking about this whole chunk in here. So if we're going to minus 180 degrees, you could have one answer within this range, okay? Because you're not going to run into both these quadrants in that time. If, on the other hand, you're talking about the other solution to, going up to a positive 180 degrees, it's going to be this way here. And again, we're only going to hit one of the quadrants in that route. So when you go from theta down to minus 180 degrees, you'll hit one answer. And when you go from theta up to positive 180 degrees, you'll hit one answer. So that means we have a total of 2 solutions. Okay? There's 2 possible answers that we can have there. One in quadrant 1, as we identified, and one in quadrant 2. So that's all they're asking you to do there. So as you work through the other questions, just think about what do these values mean, and think about what x and y's are you using for them, and then how many times will you run into that within the domain. So this is just sort of primer question. It's using what we've been doing from 4.1 through 4.3 and just getting us a bit of a reminder before we get started with some of the 4.4 questions. So let's do that as a bit of practice to make sure we're all up to par on the skills we need, and then you can advance on to the next set of questions. So that's all for now. I'll see you in the next video.